Hello everyone, good evening, how are you all? So yes, welcome back at Exampur. Here we are going to discuss previous year questions of CGL. Which topic? The topic will be periodic table, and yes, this is the first class of chemistry. So what we'll do, we'll start with the previous year questions. Along with that, we'll be covering the theoretical section as well. That is, today we'll be covering most of the questions which will be from previous year questions. And yes, along with those questions, we'll be understanding that particular theory. So okay, without any delay, let's go with the first question. What's the first question? The first question is, who among us the following gave modern periodic law? So was he Faraday, Mosley, Newton or Bohr? So let's see who is the first one to answer this. And yes, who all are present here, kindly give me your attendance so that we can start talking with each other. And yes, along with those discussions, we'll be going in the detailed manner. That is, we'll be discussing all the options which are present here. Okay, so yes, when we'll talk about this question, that is modern periodic law, please do not get confused. In the morning when we were discussing about several examinations, where we were discussing about CPO, CHSL, all those examinations, a question similar to this was framed. And the question was, who gave periodic law? Now there's a difference between two. If someone is asking you, who was the one who has given periodic law, and there are several options which are given, please go with the option Mendeleev. See, this is the question which is quite twisted. That is, the only word which is added here is modern. So there's a difference between both the questions. Please try to understand. In the starting, when this periodic table was being made, the present periodic table, which we call modern periodic table, was actually the idea of Mendeleev. Who was he? He was Mendeleev. Now this is very important thing. When Mendeleev proposed this particular periodic table, he used which logic? Mendeleev was using the logic of atomic mass. Very important thing. At that time, the logic of atomic mass was there. But the issue was, there were certain things which were not applicable, or there were some issues which were not eradicated by Mendeleev. What happened? In that particular periodic table, there were some things that changed, and the main thing that changed was here the concept actually came of what? The concept of atomic number. Very important thing. This is asked in the examination. Please remember, when we are talking about the atomic number, this means we are talking about the modern periodic table. But Mendeleev was the one who was actually proposing the periodic table according to the atomic masses. Fine. So okay, please remember, when someone is asking you who proposed periodic law, so he was Mendeleev. But if someone is asking you who proposed or who gave modern periodic law, so he will be Mosley. So there's a difference between two. Never get confused with this part. Fine. Since we have for the CGL examination, we must be knowing this particular part, and yes, never get confused with this. So again, I'll say Mendeleev was the one who gave the concept of atomic mass with the periodic table, and the issues which were there actually were resolved by Mosley, and Mosley is the one who has actually given you modern periodic table. So I guess both the things are clear now. Okay, so here option number B was the correct answer. Let's move forward with the next question, and then we'll have a look at modern periodic table, and then I'll be asking you some of the questions which are very important. And yes, not these one, from the periodic table itself. While explaining, I'll be just asking some of the important questions which are again and again asked. So let's move forward with the next question. Next question is, what is the common characteristic of the elements of the same group in the periodic table? Now we have just seen this group. What is this group? So I'll be explaining this part, but before that I want answer from you all. The question is, what is the common characteristic of the elements of the same group in the periodic table? Now this question is from CGL 2017. What are the options? The options are electrons in the outermost shell, total number of electrons, total number of protons, or atomic weight. Now, group, what is that? So before going with this question, let's have a look at the periodic table. See, when we talk about periodic table, what happens? Here, if I talk about horizontal rows, they are known as what? They are actually known as periods. But if I talk about these vertical columns, these are what? These are actually known as groups. So yes, we are going to have look at that particular periodic table, but all of you who are present here, kindly give me your attendance and yes, like this session. Please give me this answer. I'm asking, what is the common characteristic of the elements of same group in the periodic table? Yes, so here we have Mahesh, that is LTM Coach B. Hello, how are you? So yes, my question is, I'm asking you, what is the common characteristic of the elements of same group? That is, if I talk about any of the group, let's talk about first group. Halina ki rab se faryad. Remember? So what will be common in that? Electrons in the outermost shell, total number of electrons, total number of protons or atomic weight? It's very obvious. The correct answer will be electrons in the outermost shell. Now, what is this electrons in outermost shell? You're right. Electrons in the outermost shell represents what? They represent valence electrons. Valence electrons. But do not get confused with this valency and valence electrons. There's a difference between two. There's difference between both. I'll be telling you what is valency. But right now, please try to understand. Electrons in the outermost shell is known as valence electron. Now, let's have a look at the periodic table. This is the periodic table. Now, if I'll see here, 1, 2, 3 and so on till 18. These are what? These are actually known as groups. Now, we'll be understanding what is that valence electron. Fine. And if you have any doubt, please let me know right now. Now, if I talk about these particular rows, 1, 2, 3, 4, 5, 6, 7. If I talk about them, they are what? They are actually known as periods. So we have understood what are rows and what are groups and what are periods, right? Now, if I'll go with the first group, that is Halina ki rab se faryad, you can create any kind of trick, whatever you feel like is good. If I'll go with the first group, please remember, the outermost shell is going to have what? Similar number of electrons. Now, how? Is there any example? Yes, we have. See, first of all, we must be clear with the modern periodic table. We must be clear what is atomic number. So, in the sequence order of this atomic number only, this particular table is created. How? Hydrogen's atomic number is 1. Helium's atomic number is 2. Then lithium's atomic number is 3. So, in the similar manner, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have sodium, magnesium. This is in the sequence order and we must remember the sequence order is till 20. Now, sequence order 1, hydrogen, then helium, then lithium, that is 3, right? Then beryllium, 4, 5, 6, 7, 8, 9, 10. Then 11 is with the sodium. Now, you must be wondering, sir, how we can talk about the outermost electron? How many electrons will be there in the outermost shell? Let me tell you, there's a formula. Please remember, there's a formula that is 2n square. Very important. It is asked in the examination, so do not forget. Everyone, please remember this part. Do not forget what I'm talking. We have to remember the formula 2n square. Now, what is n? N is actually the number of shell. Just have a look. If I draw these shells, these are what? These are actually electrons which are revolving around the nucleus. For every element, whether it is metal, non-metal, whatever it is, we have shells. The innermost shell is represented by K, then L, then M, and then so on. That is K, L, M, N, and so on. Now, since we are talking about the first shell, innermost shell, number 1, let's put the formula. 2 into 1 square, it will give you what? 2, right? If I talk about the second shell, that is L, second shell. So, 2 into 2 square, it is what? 2 to the 4, 4 to the 8. That is, in the innermost shell, we can have 2 electrons and then we can have 8 electrons, right? Now, let's have a look. What you are saying, for hydrogen, we had atomic number 1. This means when I'll try to put the number of electrons, I'll use this formula. So, in the innermost shell, how many electrons can come? 2. But here, atomic number is 1. That's why we'll say that we will have only 1 electron in the outermost shell. Then talking about lithium, we have atomic number 3. Innermost shell, 2 electrons. 2, what is left now? 1. So, here we have 1 in the outermost shell. Then let's talk about sodium. What was the atomic number? 11, right? So, how I am going to write its configuration? Innermost shell, 2, then 8. How many? 10. How much is left? 1. So, just have a look. 2 plus 8, 10 and 1, 11. Now, try to have a look. Outermost shell is having same number of electrons, right? So, in the similar manner, if I'll go with the second group, fine. In the second group, I'll be having outermost shell with 2 electrons. In the third, I'll be having outermost shell with the 3 electrons. So this periodic table was actually created in such a manner that the first group will have only 1 electron in the outermost shell. Second will have only 2 electrons in the outermost shell. No matter it is beryllium, it is magnesium, calcium, whatever it is, it will have only 2 electrons in the outermost shell. In the similar manner, if I'll go with this, actually there is 3A, 3B, something like that. Okay, so here we'll be having 3 electrons in the outermost shell and so on. So our question was what? Our question was, what is the common characteristic of the element of the same group? Same group will have same number of electrons in the outermost shell. Simple. Let's move forward with the next question. Next question is, among the given elements, which comes first in the periodic table of the elements? Very simple question. Let's see who answers this. And everyone who is there in the session, kindly like it and share it. We are going to discuss everything in the detail, but I need your, please, I need you all right now. So let's get together and understand these concepts. Waiting for the answer, please. Among the given elements, which come first in the periodic table of the elements? So is it sodium, neon, potassium, silicon? What is the correct answer? Okay, Mahesh, fine. And yes, everyone who is there in the session, kindly give me these answers so that we can go in the details, and whatever doubt is there, please let me know. Yeah, so what was the question? If I'll go with these particular options, sodium, neon, potassium, silicon, can we try to create that table? Yes. We had a trick. What? Halina ki rab se faryad. Remember? That is hydrogen, lithium, sodium, potassium, rubidium, then cesium, francium. Then if I go here, beta, mange, car, scooter, baap, razi. Remember that part? Now here, if I try to write them out, what were the options? First option is sodium. Then we have here hydrogen, helium. Then we have neon, argon, krypton, xenon. What's there? Then we have potassium. We have helium, neon here. Then we have potassium here. Now, if I'll talk about carbon, so it would be carbon, silicon. Kahe Shivji, Sune Parvati. Remember? So here we have silicon. Now let's try to have a look. Which is the first element that is coming? Which is the first element that is coming? 1, 2, 3, 4, 5, 6, and if I'll go with the sequence order, remember here neon is coming first. Got my point? So here what is going to be the correct answer? We will be having correct answer, that is neon. Simple. So the best part is just try to create your own tricks. As I was saying, Halina ki rab se faryad, beta mange car scooter baap razi, kahe Shivji sune Parvati. You can create any kind of trick which is actually suiting you, whether in English, whether in Hindi, whatever is your official language or whatever you find easy. Just create your own trick and try to relate it. Okay, so here neon is the correct answer. Next, the modern periodic table consists of 18 groups, 7 periods. What is the atomic number of the element placed in the second group and fourth period? So yes, before getting this answer, let's try to create the periodic table again. That was hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. This was the one. Now, if I try to move forward, I know this is the first period, this is second period, this is third period, this is fourth period. Now we had a trick. What was the trick? Halina ki rab se faryad. Remember that part? Beta, mange, car, scooter, baap, razi. True? Then we are talking about the second group and fourth period. Just have a look. This was the first group. This was the second group. Now the question was, what is the atomic number of the element placed in the second group and fourth period. Fourth period, that is we have calcium over here. Now what is the atomic number of calcium? Right, that is 20. Correct? So here what is the correct answer? If I'll go with this question, so the modern periodic table consists of 18 group, 7 period. We already know that. What is the atomic number of the element placed at the second group and fourth period? That is calcium. Option number A, that is 20, will be the correct answer. So Mahesh, did you get this? And everyone who's there in the session, did you get this? If there is any sort of doubt, just let me know. I guess this is clear now. So we can move forward. Okay, so let's move forward with the next question. Before moving towards the next question, just have a look at the sequence order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So can you see we have actually kept these particular elements in the increasing order of their atomic numbers. In the starting, in the first question, what we discussed, if I talk about the modern periodic table, that is actually given by Moseley. No doubt, this idea was actually in the mind of Mendeleev, where he was discussing about atomic masses, but modern periodic table is according to atomic numbers. Here, in the increasing order of their atomic numbers, we have placed our elements. And yes, if I talk about the 20th number, that is of calcium, and hence calcium is having the atomic number 20. Simple. Till now we have understood what is atomic number, we have understood what is valence electrons, these things. Now let's move forward with the next question. Before moving forward to the next question, we have Exampur official application, which is one-stop solution for the government job aspirants. What all things are here? We have live paid course with the test series. We have free subject-wise and topic-wise quizzes with the report card. We have job alert, admit card, examination date, all exam previous year PDFs with the solution, free all India scholarship test with the report card. Then we have topic-wise free live classes. We have free full-length and sectional tests with the report card. We have free exam-wise PDFs and practice set PDF. We have daily, weekly, monthly current affairs. We have unlimited subject-wise practice questions. All these at a single platform. What do you have to do? Just go to the Play Store, type Exampur app over there, click on the install button, click on the open part, just do the registration and start using it. Okay, so we have discussed all these things till now. Now we have to discuss, if I'm talking about these elements, can you tell me what is the total number of elements that is present in the modern periodic table? Again, a question which is asked in the examination many times, no matter it is CGL, CHSL, MTS, whatever exam it is, this question is asked. My question is, if I talk about modern periodic table, what is the total number of elements? Total number of elements. Yes, please. And yes, I am talking about modern periodic table, no doubt. So, can you give me this number? This number is actually asked in the examination. So, Mahesh, are you there in the session? And everyone who is there in the session, please answer this. What is the total number of elements? If I talk about the total number of elements for the modern periodic table, please remember, it is 118. This is asked in the examination and we must know it. Okay. So yes, if I'm talking about the modern periodic table, we have 118 elements, out of which if I talk about these elements, we have their symbols. For example, if I talk about iron, we have a symbol that is Fe, right? If I talk about gold, silver, so these symbols are Au, Ag. What's that? These are actually taken from the Latin name. For example, ferrum, then we have argentum, we have aurum. In the similar manner, if I'll go with this part, Rn, it is the symbol for what? Is it for radium? Is it for radon? Is it for rhenium? Or is it for ruthenium? So please remember, this Rn stands for radon. And we have Gobinath here. Yes, Gobinath, you are absolutely correct. If I talk about Rn, it is actually denoting what? Radon. And radon is what? Radon is actually present in the 18th group. And 18th group is what, Gobinath? This is actually the group of noble gases, right? So yes, if someone asks you about the radioactive gas, then also you will tick radon. It is present where? In the 18th group. Okay, so here we have discussed all these things. Let's move forward now. So I was talking about this 18th group. So I have one more thing which I have to explain here. 18th group is the one which actually do not want to donate electrons, neither they want to take electrons. Now there's a reason behind it. Please try to understand what happens if I talk about our example, whether it is Gobinath, Mahesh, I, whoever it is, we all want our life to be stable, right? Whether it is in the terms of money, whether it is in the terms of family, we want our life stable. Same is the case with these elements. If I talk about elements, what they want their outermost shell to be complete. Very important fact. They want their outermost shell to be complete. Very important part. Now, what does this mean actually? What it means to be complete with the outermost shell? What happens if I talk about any of the element? They want that in their outermost shell, there must be either 8 electrons, and for some of the cases, there must be 2 electrons in the outermost shell for their stability. If I talk about 8 electrons completion, we call it octet. If I talk about 2 electrons completion, it will be known as duet, where we can take the example of helium, for example. Now, if I talk about this 18th group, these are already having their outermost shell complete, so they don't neither want to donate the electron nor they want to take electron. But the case for 1 to 17th group is quite different. Now what's that? We'll be having one of the question, then we'll discuss about it. Okay, let's move forward to the next question. How many elements are there in the periodic table such that for every element name there is a single word? For example, if I'll talk about carbon, we have only symbol C, right? In the similar manner, there are several elements which are only having a single letter. Now, how many number, actually, what is the total number of elements with just a single letter? Can you tell me? As I have already given the example of carbon, but if I talk about gold, silver, we have Ag, Au, that is two-lettered symbol. I'm talking, I only want the total numbers which are only and only with the single lettered word. So can you tell me, single lettered word, how many are they totally? Are they 10, 17, 7 or 14? Now all these questions are previously asked, so want answer from you all. What would be the correct answer? Will it be 10, 17, 7 or 14? What is going to be the correct answer? If you want, I can write some more for you. For example, I can talk about hydrogen, just a single letter. But if I write He, it will be two letters, right? So we are talking only about these single letters. I can write many. So just want the answer. So yes, who all are there in this session? Kindly answer this. So Gobinath is with 7, okay? Gobinath, but you are exactly half of the correct answer. So yes, let me tell you, if I'll go with the correct option, that is going to be 14. That is exactly double of what you are thinking. Now you must be wondering, sir, what? 14? Yes, they are 14. So just have a look. Who all are they? Hydrogen, 1. Then we have boron, carbon, nitrogen, oxygen, fluorine. Then we have potassium. So all these, if I'll count them, they are actually what? They are actually 14 in numbers. So this was asked and it must be there. No issues, Gobinath, no issues, but it's the thing. Okay. So yeah, there we have 14 elements actually starting with the single letter. So yes, we have already discussed about it. Let's move forward now. In a periodic table, while moving from left to right in a period, the number of dash remains same. What would be the answer? And everyone who is there in the session now, kindly start answering this, because I want to go in the details, but I can only go in the details when you just start conversation with me. So I just want you all. Otherwise, I'll do one thing. I'll just present you a lecture with only theoretical section for this periodic table. No worries. But here, please start answering so that we can go in the depth with each and every question, with each and every option. Yes, answer please. So Gobinath, can you answer this? In a periodic table, while moving from left to right in a period, number of dash remains same. Now see, when I'm talking about the periodic table, just have a look. If I talk about the periodic table, this would be my left and this is going to be my right. Now there are several things which I have to explain here. First thing is, when I'm moving from top to bottom, for example this, Halinagi Rabse Faryad, that is hydrogen, lithium, sodium and all. If I'll move from top to bottom, here the number of shells are actually increasing. Please remember this part. The number of shells actually increases from top to bottom. But when I'll go from left to right, the number of shells are going to be same. The number of shells are going to be same. Now please remember this fact. One more thing is here. When I'll try to go from left to right, what is happening? The nuclear force or nuclear force of attraction actually keeps on increasing, because of which what happens, the outermost electrons are near to this nuclear are actually near to this nucleus. Why? Because we know that there's a positive charge in the center and the electrons are revolving around it, so there must be some force of attraction because of the opposite charge. Now you can relate this with the boyfriend-girlfriend example. If I talk about the boyfriend and girlfriend of the college time, they're actually near to each other, sitting in the class together, going in the park together, going into the restaurants together, right? Force of attraction is more. What if we talk about the long distance relationships where they are far apart? In this condition, what happens? The force of attraction actually, when it is far apart, because of the long distance, actually, what will happen? Here the force of attraction would be lesser. So please remember what is happening when we are going from left to right. this nuclear force is actually doing what? They are actually keeping the electrons towards themselves. And yes, please remember what is happening because of that electronegativity. Now there's a new word. What I said? Electronegativity. Please try to understand what is this. I'm writing here electronegativity. Now what is electronegativity? We know that what happens if I talk about non-metals. Non-metals actually want the electrons. Why? There's a reason. If I talk about 17th group, we have chlorine. Fine. Now for the chlorine, can you tell me what is the atomic number of chlorine? Anyone? Gopinath and others who are present in the class, can you tell me what is the atomic number of chlorine? Very important, so that we can understand this particular electronegativity easily. Can you tell me what is the atomic number of chlorine? Yeah, answer please. And apart from that, I'll be requiring one more answer for the sodium as well, which is actually there in the first group. Now from here, we'll be easily understanding what is electronegativity and what is electropositivity, and then we'll go with the ionization potential. So Gopinath, you are absolutely correct. If I'll go with the chlorine, we have its atomic number, that is 17. What about sodium, Gopinath? If I'll go with the sodium, I'll not ask you, I'll directly tell. Sodium's atomic number is 11. Now let's try to relate it. For the first group, we had Halina ki rab se faryad, right? So here, if I'll talk about the first group, its atomic number is 11. And if I'll go with the 17th group, here we have chlorine, which is having actually a 17 atomic number. Let's try to make its electronic configuration. For this, what will be the electronic configuration? Remember, 2n square formula. It is 281. And for it, what is going to be the formula? 287. Now, what is going to happen? I told you, like us, they also want this stability in the life. Now, for the stability, what they'll do? They want the outermost shell to be complete, either by 2 electrons, for example, helium, and for them, 8 electrons, octet, right? So, just have a look. They have options. Either he can donate, the sodium can donate 1 electron or can take 7. What's easier? Obviously to donate. So it will do what? It will actually donate the electron towards this chlorine. This chlorine is already having 7 and it will gain 1 more. So what is the new configuration? New configuration is 28 and it will be 288. Got my point? So what is happening? Here, this sodium, when it gave the electron actually went away from him. So here, it is going to get the positive charge. Electron just moved away from him. And if I talk about chlorine, electron actually came here. So here there was a negative charge. Now we know that positive and negative charges attract each other. So I'll write what? NaCl, where it was positive, it was negative. And here, it's the same salt that you're eating, that is a sodium chloride. So yes, who was the one who has taken the electron? This was chlorine. Who was the one who gave the electron? This was sodium. So the one who give the electron is metal. The one who takes the electron is non-metal. Now from here we have many of the concepts that are clear. Whenever we write, this is the question which is asked in the CGL. Whenever we write any of the formula, which thing comes first, which comes second? Now there would be 4 options. Please remember, the first one is always metal and second one is always non-metal. Whenever we write any of the formula, this is the fact. Got my point? Second thing, we were talking about electropositive and electronegative character. For the electronegativity, we had what? Tendency to gain the electrons. So where we will have tendency to gain the electrons? Obviously in the right part. That is when you will move from left to right section. Whenever you will move from left to right section, this is the part now which actually wants the electron. So these are actually the most electronegative part and this is actually the electropositive part. These are the non-metals and here we have metals. I think all the things are clear. Which one are metals? Who are giving electrons? They are giving electrons. Why? To complete their octet or duet, right? They have 1 electron in the outermost shell. First group. Second group will have 2 electrons in the outermost shell. Third one, 3 electrons in the outermost shell. So obviously they are giving 2 electrons and they are having octet complete or duet complete, right? In the similar manner, these are actually gaining electrons, non-metals, and in the same concept, they're actually completing their octet or duet. So this is the effect how this actually bonding is done. That we'll be having discussion on the chemical bonding part as well. Don't worry about that. But right now, let's have a discussion on electronegativity and electropositivity. So for the positivity, it is actually opposite of electronegativity. So electronegativity, tendency to gain the electrons, which will be towards right. Got my point? But if I'll go from top to bottom, electronegativity will decrease. Fine. So yes, is this particular thing clear? If there is any sort of doubt, please let me know so that I can explain it in the detailed manner again. Are these things clear? If these things are clear, I guess you will be having all the doubts cleared up. So yes, can you answer this part? All these things are clear now. Gobinath, then we have Mahesh, all those candidates who are present right now. If there is any doubt, let me know. Okay, so we cleared up electronegativity, electropositivity, right? Next, we have a question. Which of the following atoms has the lowest ionization potential? Now, what is this ionization potential? Let's have a look. I was discussing about electronegativity, electropositivity. We have understood what are metals, non-metals, how these electrons are donated. We have understood. Now, the thing is that what is ionization potential? Ionization potential is actually the energy which is actually required to remove electrons from the outermost shell. Ionization potential energy. Can you give me this answer? Which, from where we will be requiring least amount of energy to take out the electrons. I just gave you the example of long distance relationship where we were talking about the number of shells. Just have a look. When I'll go from top to bottom, what is going to happen? The number of shells are going to increase. When the number of shells will increase, that means in this case, there's a lesser force of attraction. And when there is a lesser force of attraction, these electrons can easily be taken out. Correct? So here, please remember, if I talk about the lowest ionization potential, it will be in the bottom of the periodic table. From top to bottom, this ionization potential actually decreases. Fine, because we require lesser amount of energy to just take out the electron. So if I talk about this question, can you answer this? Which of the following atom has the lowest ionization potential? So what is the correct answer for this? We have 4 options. Answer please. If these things are clear, I want the answer. Will it be nitrogen, cesium, oxygen, arsenic? What is going to be the correct answer? Please, answer please. So yeah, waiting for the answer. I have just explained this part. Minimum amount of energy to take out the electrons. If I'll write these things, we have so yes, try to relate it. And yes, we have cesium as well, right? So it was Halina ki rab se faryad. Remember? So here we have cesium over here. We have yes, then we have what is left? Oxygen here. Then we have nitrogen here. If I'll just try to relate this with the periodic table, I know that Gobinath is saying so it cannot be N and O. That's true. Totally correct. It cannot be N or O because it is in the topmost part. Now Gobinath, let's try to relate with these 2 options. See, just have a look. It is present where? Here. And cesium is where? Here. Now just try to relate the concept what I told you. Easily electrons can be taken out from the lowermost part. Now just try to relate the lower order. Which is above? AS or CS? Obviously, the correct answer is going to be option number B. Got my point? So here, Gobinath, is this concept clear? And everyone who is there in the session, kindly start giving answers so that we can start discussion. I know these are the things which create confusion in the examination, but once logic is clear, na, everything is sorted. So that's why I've kept this in the first lecture itself. So here, Gobinath, what I told, when I'll move from top to bottom, here electronegativity, ionization potential will be lesser, right? Because easily electrons can be taken out. So what is the correct answer? The correct answer is B. Got my point? Gobinath and others. Fine. Okay, let's move forward. So here we had cesium, we had nitrogen, oxygen, and then we had arsenic over here, right? These were the options. Just try to relate it. Arsenic is in the 4th period and cesium is in the 6th period. And that too, if I'll go with this cesium option with the lowermost part. Okay, great. Let's move forward now. Which of the following does not increase while moving down the group of the periodic table? We have understood each and everything now. Let's see. Can you give this answer in the first go? Which of the following does not increase while moving down the group of the periodic table? The number of shells in the element, Metallic character, valency or atomic radius? What is going to be the correct answer? Answer please. And everyone who is there in the session, kindly start giving the answers. All these questions are very important. Once your concepts are clear, no need to revise also. Seriously. Yeah. So what I was saying, which of the following does not increase while moving down the group? First of all, Gopinath is with B. Okay, metallic character. Gopinath, let's try to understand this. If I'll go towards the bottom part, I know number of shells are increasing. So first of all, this option is wrong. Then, if I talk about atomic radius, let's check. Nucleus, electrons, nearby. Nucleus, electrons, far apart. What is the radius, atomic radius? Just try to calculate the distance from this center part of the nucleus and this outermost shell. It is increasing, right? So this means atomic radius is also wrong. It is going to increase. Now what's left? Valency and metallic character. So before going to valency, let's talk about metallic character. What is metallic character? Metallic character, that means we are talking about metals. That is easily who can donate the electrons. Try to understand. Easily who can donate the electrons. Here we can say that if I'll go from top to bottom, these electrons can easily be donated because it is far apart from this positive charge. Easily electrons can be donated. That means metallic character is going to increase from top to bottom. Right? So yes, metallic character is also increasing. Why? What is metallic character? If I'm talking about metals, they are easily donating the electrons. Non-metals, they are taking the electrons. So if I talk about the metallic character from top to bottom, electrons are far apart. It can easily come out. Easy? So what is left now? It's the valency. Now what's the valency? Let's try to understand. I was talking about valence electrons, right? So I'll talk about the valence electrons. In the outermost shell, what is the total number of electrons? That is valence electrons. Now, let's have a look at the periodic table. Obviously, valency is the correct answer. There's no periodic table. Just a second. Yeah. If I talk about this periodic table, please try to understand. In the first group, we have 1 electron in the outermost shell. In the second group, we have 2 electrons in the outermost shell. Here, we will be having 3 electrons in the outermost shell, 4 electrons in the outermost shell, 5, 6, 7 and 8. Obviously, since 8 electrons are there in the outermost shell, there is no need of this particular donation or taking of the electrons. But since we have 2 electrons in the outermost shell, what will be done? It will be donated. Who will take it? Obviously, the non-metals. But if I'll go with this part, for example, this is the second group. How many electrons can be donated? 2. So it will be having 2 electrons in the outermost shell. Valence electron also 2. Valence is also 2. But if I'll go with this 17 group, this is the best example. 7 electrons are there in the outermost shell. But how many electrons are required for the bonding? That actually gives you the valency. Remember my words. The number of electrons which are actually required to complete its outermost shell. That is exactly what valency is. So no doubt, first of all, this valency will actually increase, but here valency will decrease. This 5 electrons are in the outermost shell, so it only requires 3. So I'll use red here. It only requires 3, so that 5 plus 3 will be 8. It only requires 2 electrons, so that 6 plus 2 will be 8. Non-metals now. If I talk about these, only 1 electron is required, but it will be donating 1 electron. It will be donating 2 electrons. It will be donating 3 electrons. Here, 4. So please remember how many electrons are actually required so that outermost shell can be complete. This gives you what? This gives you valency. And what is the valence electron? The outermost shell is containing how many electrons are known as valence electrons. So are both these things clear? Are both these things clear? Very, very important fact. Again, I am saying outermost shell is having how many electrons? That is valence electron. But how many electrons can either be donated or can be taken in order to complete the outermost shell with that either octet or duet, whatever it is. I have to complete the outermost shell. So for that, how many electrons are either needed for the donation part or for the taking part? That is actually valency. So I have already written this red part would be valency and valence electron I have written with the blue color. I guess this point is clear. Gopinath, everyone. Okay, Udbhav, great. Thank you for that. Okay, so I guess these things are clear. Let's move forward with the next question. Next question is, ionization potential for the inert gas is dash. Now we have understood what was ionization potential. How much energy is actually required to remove the electron from the outermost shell. Remember that part? Answer please. Ionization potential for the inert gas is what? Is it 0, low, high or negative? What is the correct answer? And no doubt this question I kept in the morning itself. Why? In the morning this was question which was asked in the CHSL and other examinations, but this question is also asked in CGL, and yes, it's very important to actually not only qualifying CGL but other examinations as well. So Gobinath is with A, that is 0. Gobinath, how much energy is required for an inert gas to take out that electron? So if I want to take out electron from this inert gases, what are they? That is, I am talking about 18th group. If I talk about helium, neon, argon, krypton, since their outermost shell is already complete, they are not going to involve on this bonding and all. Fine. So Udbhav is also with it. Okay. So this means if I talk about the electrons in the outermost shell, I cannot actually remove them. I require a very huge amount of energy to remove. Why? Because they are already stable. They neither want to give electron nor they want to accept electrons. So they are already stable. They will not involve in all those things. So if I talk about ionization energy, what was that? The amount of energy required to remove the electron. So here you will be requiring a very huge amount of energy because they are already having their octet complete, right? So yes, outermost shell is already complete. They are not going to involve in this part. So ionization potential will be very high. Gobinath, is this point clear? Very important. Please remember, for the 18th group, they are not involving in such activities. Fine. So yes, it is going to have very high ionization potential. Next. So this is the 18th group. We are talking about helium, neon, argon, krypton, xenon, then radon. Okay. Next, the correct order of electronegativity of FNOP is what? Now we have discussed this part. So I want the answer. I am talking about the correct order of electronegativity. What is the correct answer for this? Correct order of electronegativity. Answer please. If you want, I can help you out with the periodic table as well, but I want answer for this. Let me write for you all. We know that hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now here we have the options from F, N, P, N. Okay. So I'll write here. Nahi Priyanshi as Surbhi. Then we have O se Tipo. Then we have Fasal, Variat. Then we have neon, argon, krypton, xenon and all. So we have options that were given. What were they? So we have here F, we have O, we have N, right? Then we have P. So these are the things. Yeah. So can you answer this? The correct order of electronegativity. If you want, I can again explain. Electronegativity is actually increasing from left to right. That is, if I talk about the periodic table, from left to right, electronegativity will increase, and if I talk about electropositivity, it is going to decrease. So I guess now you can give this answer. Answer please. And everyone who is there in the session, please try to understand all these facts. Very important for the examination. Yes, if I'll go from left to right, obviously the maximum electronegativity will be for what? Fluorine, then oxygen, then nitrogen. And yes, one more thing, when I'm going from top to bottom, this electronegativity is going to decrease. We are aware of this fact. So what will be the maximum one? The maximum will be for fluorine, then oxygen, then nitrogen, then phosphorus. So it will be FONP. FONP. So what is the correct answer? The correct answer is going to be option number C. Very important. And if you have any sort of doubt, please let me know. I guess this point is clear to everyone. We have understood. That was FONP, right? So yes, FONP is the correct answer. If you have any sort of doubt, please let me know. Any sort of doubt? All okay? Let's move forward. Next, according to Mendeleev's periodic law, the elements were arranged in the periodic table in which order? According to Mendeleev's periodic law, the elements were arranged in the periodic table in which order? Answer please. Answer yes. And please think twice before giving this answer, because this one is important. We actually click on the wrong answer just after seeing the modern periodic table, right? So yes, here have a look at the name. What is that? Mendeleev. And I have already discussed Mendeleev and Moseley, both are different. But I want answer from everyone. So Gobinath, can you answer this? All the candidates who are there in the class. So Gopinath is actually with C. So that is increasing atomic number. Okay. Gopinath, Udbhav, everyone who is there in the session, please remember, when we are talking about Mendeleev, Mendeleev was the one who actually gave the concept of atomic mass. But if I talk about the modern periodic table, that is Moseley, he gave the concept of atomic number, which we are actually studying. Now, question is asked regarding Mendeleev. So it's very obvious the correct answer will be what? The periodic table which was actually created according to Mendeleev, that was according to the increasing atomic masses. Right now, Gopinath, that we are talking about, that is for the Moseley, the present periodic table that we are studying. All the concepts that we have studied today are according to the atomic number. But the Mendeleev, when he gave according to the atomic mass. So please remember, what is the correct answer? The correct answer will be increasing atomic masses. Gopinath, I guess I am able to explain this point. Very important. Please do not forget. Fine. Okay. So next question, please. Now we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. They belong to which period of the modern periodic table? Very simple. Okay, Gopinath, great. So I'm sure you will be correct now. Whenever you have any doubt, just let me know. But answer for this part, please. What is the correct answer for this? Now this is a very simple one. Answer please. Sodium, magnesium, aluminium, silicon, phosphorus. All these belong to which particular period? So 3, 2, 4, 1. What is the correct answer for this? And yes, everyone is requested to please answer this. As this is a simple one, na? Everyone can give this answer. Should I write periodic table again to explain this part? If you will take time, I'll write for you. Fine, writing. We have first hydrogen. Sequence order. Remember, I told you just remember the sequence order. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now we are asked about sodium, magnesium. Okay, I'll write here. हलीना की रब से फरियाद, बेटा मांगे कार स्कूटर बाप राजी, बैगन आलू गाजर इन थैला, कहे शिवजी सुने पार्वती, नहीं प्रियांशी या सुरभि, ओस से टीपो, फसल बरियात, helium, neon, argon, krypton and on. Okay, so what are the things that are asked in the paper? We are asked about sodium. Okay, then we are asked about magnesium. Remember this part. So Gopinath has already given the answers of 3. Great. Then we have aluminium, we have silicon, we have phosphorus, we have sulfur, we have chlorine, we have argon. All these things are present. And I have already told you when we talk about period, which are they? They are horizontal rows. 1, 2, 3, 4. Right? And these are what? These are actually groups. So yes, this is the first one, second one, third one. So it's absolutely correct, Gopinath. Very, very awesome. So yes, that's true. Here option number A, that is 3, is going to be the correct answer. I guess you can relate this, right? Okay. So here we have A, that is 3, correct. So we have understood. Just have a look at the periodic table. First period, second period, third period, and this was actually asked here. Okay, next. So let me tell you about the Exampur official application. We have one-stop solution for the government job aspirants. We have live paid courses. We have job alert, admit card. We have daily, weekly, monthly current affairs. All these at a single platform. Just go to the Exampur app. How you are going to do that? Just go to the Play Store, type Exampur app. Just click on the install button, click on the open part, just do the registration and start using it. Okay. So we have next question. In which group of the modern periodic table we have halogens placed? Important. Actually, it is very important. It is asked in the examination again and again. Yeah. So in which group of the modern periodic table we have halogens? So till that time you're giving me answer. Udbhav, awesome. That's totally correct. Great. So what I was talking about, if I'll talk about the groups, how many are there? If I'll talk about group, we have 1 to 18. Right? So I'll talk about the 18th group. These are actually noble gases. But if I'll talk about 17th group, so we have what? We have fasal bariyat, where we have fluorine, chlorine, bromine, iodine. All these are actually known as halogens. Please remember, 18th one was noble gases. If I'll talk about the 17th, so these are actually halogens. Halogens. So yes, if I'll talk about halogens here, so where is it placed? Mnemonic. Okay. So that was actually, if I'm talking about the sequence order, that is the sequence order which you have to remember. What's that? According to the atomic number, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Fine. So it is actually in the sequence order. So I'll write here hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then if I'll go with this sequence order, so the first group is हलीना की रब से फरियाद, that is hydrogen, lithium, sodium. Second one is beta मांगे कार स्कूटर बाप राजी, fine. Then if I'll go with the third one, कहें शिवजी सुने पार्वती, that is कहें C, Shivji, SI, in this sequence order, fine. So if you want any of the specific group, just let me know. Okay, so here what I was talking about halogen, so they are actually belonging to the 17th group. Got my point? So here option number D, that is 17, will be the correct answer. Next and last question of the day. The question is, which one of the following is the correct order for the valencies of elements neon, silicon, then we have nitrogen and magnesium? Can you give me this answer? We are talking about the valencies and we have already understood what was the valency. So I guess class is buffering, right? So if there is any issue, please let me know in the comment section. Yes, I am talking about the correct order of the valencies. Can you give me the correct answer? Correct order of the valency. What is the correct answer over here? And yes, is there any issue in the class right now? You can just comment and let me know. If there is issue, we'll do what? We will just try to understand these concepts tomorrow. Is class hanging? Everyone is requested to kindly answer this. And yes, please answer this part. We are talking about the valency. What is the correct answer for this? Answer please. No one? I guess it is hanging, huh? Okay, so Gobinath is with A, that is neon, then magnesium, then nitrogen, then silicon, and you are absolutely correct. Udbhav, Gobinath, both of you are absolutely correct. So we have already understood. If I talk about the valency, so for the neon, it is not going to react with anyone, so it is going to have zero valency. Then if I talk about magnesium, so where is the magnesium placed? So we know hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So here we know that valency will be 0. Here we have 1. So what is ours? Neon. So neon is here, that is 0. Then we have magnesium. Beta mange car scooter baap razi, right? So we have valency 2. So we will be having valency 2 over here. Then we have nitrogen. Nitrogen is present here, right? So we have 1 here, 2 valency here, 3 here. So for the nitrogen we have 3 valency. And C, kahin Shivji sune Parvati. What is that? Valency is 4 here. So yes, if I talk about the valency, so it is increasing in this manner, 0, 2, 3, 4, right? So here, Gobinath, Udbhav, both of you are correct. Awesome. Here, the correct answer is A, that is this sequence order. So it's awesome that you all were here with as a wonderful audience. Tomorrow, we'll be discussing with the chemical bonding part. Fine. And again, I'll be keeping the question answer session for the CGL part. And along with these questions only, we'll be covering with the theory section, right? Okay, so thank you for being such a wonderful audience. I'll be meeting you all tomorrow at the same time, 6 to 7 for the CGL and 12 to 1 for other examinations apart from CGL, that is CPO, CHSL and all. Okay then, bye-bye everyone. Please take care. And if you have any sort of doubt, just let me know in the comment section or tomorrow during the class. So bye-bye. Please take care.